Okay, so we just collected the students' papers, looked at your vocabulary, and I thought, well, let's take a look at this. In the first Santa Claus movie, what was the velocity that Santa hit the ground if on impact there was 20,000 joules, which measures what? Joules measures one of two things. Energy or work, okay? If that's how much was exerted onto Santa's body when he hit the ground in the movie, his mass is 170 kilograms. So approximately how fast was he moving? That's what we're trying to figure out, because one of the things we have not done yet was use a specific formula to solve for velocity, because one of the things we said, from human nature, what is it that a student might forget to do when utilizing the kinetic energy formula? There's a couple things, but probably the most common might be what? First of all, what formula are you going to use? Okay, well, maybe so. But let's look at your formula first. What is that for? What type of energy is this, first of all? Because we're solving for this, that is a clue. If you're solving for velocity, it must be which formula? Okay, so KE equals the mass velocity squared divided by 2. Okay, so since velocity is involved, like it is here, it has to be the kinetic energy formula. So just like every other time, we have read the problem. Okay, so what we know is this variable. And this is where we ask, well, how much do you think, how big is Santa? We said a little over 300 pounds, we thought. And so we said, well, we'll just say 170 kilograms. So that's probably pretty close, a little closer to 340 pounds. But yeah, I don't know, he had his, after drinking all that milk and eating all them cookies, well, maybe puts on a little more weight at this time. Okay. So our kinetic energy is what? 20,000 joules. Okay. And his mass is approximately what? Okay. This is probably one of the shorter, it's a complex problem with, per se, one of the shortest set of unknowns to do. We haven't seen anything this short, with the exception of going all the way back to August and September when we were dealing with velocity questions. You had a distance, you had a time, and you solved for velocity. So then, if we were solving for the kinetic energy, we said students may make the mistake of not squaring their velocity. But if it's the other way around now, where you have the energy and you have the mass, once they find the velocity, they may forget to do what? Square it. Not square it. Okay, let me start over, okay? If we were solving for kinetic energy and we knew the mass and we knew the velocity, students might forget to do what? Might forget to square it. But if we know the energy and we know the mass, once they've determined, well, we know what the velocity is, they may forget to do what? It's just the opposite. Say that again. The square root of that. Okay. So upon doing this, just do what the formula tells you to do, which would be set 20,000 equal to the left side. What's on our right side of the equation? Okay, we've got our mass, which was 170, v squared, because that's left over, and then divide by 2. Okay? So, my best advice, I would not divide that first. I would get rid of your fraction first. How can we do that? Cross multiply. So if we do that, 20,000 times 2 would give you 40,000 equals 170 v squared. So how do we get 170, or excuse me, how do we get v squared all by itself? Divide each side by 170, so then v squared equals whatever that is divided by 170. Okay, so 40,000 divided by 170, 235.29. But we are not done. One final step. It's what you had said here in the front row. You've got to take the square root of that, which is the funny looking thing. Looks like this. Okay, so if you have a calculator like this, you would punch in 235, actually, what is it, 0.29. Okay, and looking for the square. Okay, it's right next to the 7. Okay, so you would punch in 235.2. Oops, you can't do it like that. You have second square root, which means second next to the 7 key. Okay, then punch in 235.29. You take the square root of that, so the velocity is what? Okay, it's very easy to do. If you're solving for the energy, students tend to forget to square that. If they have the energy and they have the mass and they're solving for the velocity, they tend to forget to take the square root of that. Okay? It's easy to do, but when it comes to mistakes, we just say that's 1, try to learn from them, and 2, try not to repeat them. All right? Because one of the things that we could say that I've noticed for some of you lady basketball players, we've pressed a lot before on defense, but I don't know if we've had the option or even haven't had the ability to do that for the majority of the game. But it seems like it works for us, okay? Because for anyone who knows, if you are on offense trying to work against a pressing defense, okay, it's very, where's the defense trying to make you go if you're dribbling the ball? They're trying to make you go to here to the corner. Because once you pick up that dribble, that's why I call it a trap. You are trapped. Okay, maybe so. Okay, and it's an option. It's not wrong. It's just it goes from bad to maybe slightly better. You got to take the ball out now. I'm not saying that's wrong. It's just if that's what the situation calls for. Okay, so that is an example of perhaps problems that would be on, we would say, kind of like the final of the regular season. After this, there are no more grades until we get to the final. Okay? All right. So, is there anything you would think that a student would like to ask? You are asking it for somebody else. What might that be?
Bonus questions.
No. You know why, right?
No.
Why are there no bonus questions?
It's not an exam.
It's not an exam.
Oh, it's not?
Correct. Right.
Wait, we have a problem quiz tomorrow? Yes.
Where have you been all these
I was thinking vocab. I thought we had a vocab. I was like,
Oh, we said that'll probably be next Tuesday.
we have algebra?
Okay. Anything to add for this? Okay, we don't want to put so much material on here that students who are singing, is it choir practice, that to be so overwhelming for them. So we will just continue watching steam power with that, and problem quiz tomorrow. All right, we'll catch up to you next time.